Caching. So here we are going to talk about why you want to do caching. That's kind of obvious. And then we'll see the concept of HTTP caching. And then we are going to see how we can revalidate the cached data. It's called the conditional get. We are going to also learn how we can perform concurrency check. Sometimes it's called the conditional put. This is something like optimistic locking for RESTful application. So why caching? It will result in faster response for the client because it doesn't have to go to the server. It will save network bandwidth because the client doesn't have to go to the network or server, and reduces the server workload. It's pretty straightforward reasons. There are several different types of HTTP caches. The first one is a client cache. So if the browser is actually functioning as a client, browser certainly has a built-in cache. But if you have a HTTP client, you could actually save the responses in your own cache. Okay, so that is a client cache. So it's going to be maintained by the client. And again, if the client is the browser has a built-in cache. And then we have what is called a shared cache. This is sometimes called a proxy cache. And this is the cache that is actually being maintained in the middle of the server and the client. Okay. So if you see the picture over here, so foo.com is the server, and the client cache is basically the client side only cache. And then we have a shared cache. So, you know, like a Netflix and this kind of company is actually leveraging a lot of shared cache. There is some kind of proxy server that actually maintains a lot of the data. Okay? All right, so two different type of cache, client cache and shared cache. So let's talk about the concept of HTTP caching. So HTTP protocol defines a pretty decent set of built-in caching semantics, basically through the exchange of caching-related request headers and request responses. Okay? So it gives you fine-grained control over this caching behavior, and we'll see how we can actually control this caching behavior later on. It also provides what is called the validation semantics to make sure the caching that you have is in fact valid. The data in your cache is in fact valid even after the expiration, the cache has been expired or something like that. So we're going to actually take a look at conditional get or validation semantics in detail in a few minutes. Caching related headers. In HTTP 1.0, they have, it has expires response header. By the way, this is deprecated, even though this is still being supported by the browser and pretty much all server applications. The response header is called the cache control, which is introduced from HTTP 1.1. So let's take a look at each of these in a bit more detail. Expires header. Response header in HTTP 1.0 again is deprecated but still supported in most browsers. So expires response header tells the client that it can cache the data until specified time. Okay? So if the response contains expires and then this time, then client can cache this response until this time. It's pretty straightforward. JAX lets you set the expires header, response header, by using expires method. So this is the method that we have seen yesterday in the slide, but we haven't really talked about it, right? So response builder has a lot of method, such as accept method and all those things. And one of those methods are in fact expires. So here, the code we have is that we are going to create a brand new data object representing the current time. And you can pass that data object to expires method, and basically it will set expires with response header. Okay, so that is again supported, but we're not going to actually deal with it in our code camp because that's deprecated. So let's move on to cache control response header, which is actually better solution introduced in HTTP 1.1. So it provides more explicit control over client and proxy cache. Basically, it lets you specify who can cache and how the cache is going to be done, caching is going to be done, and how long. So it provides more fine-grained control in terms of how caching is supposed to be done. It also supports cache revalidation, the conditional get. Okay, so we'll see how those things work in the following slide. Okay, so basically, it's a replacement of HTTP 1.0 expires the response header-based caching scheme. Okay, so this is the response that contains cache control response header. So in this case, you have a private, comma, no store, comma, max age 500. Okay, so these are called cache control directives: private, no store, and max age. So let's take a look at these cache control directives in a bit more detail in the following slide. So cache control directive. Private versus public. So basically this one specifies who can cache. So if private is set, then only client can cache, but the proxy cache cannot cache it. Okay, so if you want to have a bit more privacy on your data, you can set it to private. Okay, that means your data is not going to be cached in the middle of internet. Okay, if you say public, then both client and proxy cache can cache. Okay, max age in the unit of seconds basically lets you specify how long cache is valid. Okay, so how long cache is valid? By the way, if both expires this response header and max age, the directives are set in the same response, the max age wins, meaning max age is going to override that the expires response header. That makes sense, right? No cache basically specifies how to cache in one of the how to cache. It indicates that response should not be cached. So, basically, if you want to make sure the client does not cache your data, then you can say no cache. No store indicates the client and proxy cache should not store data in the disk. So, it's possible client or proxy cache might actually save the data in the disk. And if you think that that is not desirable behavior for maybe security reasons or something like that, you can set no store. Then cache, client and proxy cache should not store the data in the disk. No transform. Some caches might in fact compress the data before it actually caches it. So if that is not the behavior you want, then you can say no transform. In that case, proxy caches should not transform their cache data, including compression. Okay. Must revalidate. Basically, asking client should always check the server before it serves up a page from the cache. Okay, so this is probably most stringent scheme that you can specify because every time data is being accessed on the client, it should check whether the data is in fact valid or not. Okay, okay, so these are cache control directives that you can specify. Now, how you can specify these cache control directive in your code. So JAX provides cache control class. Okay, so basically all you have to do is you're going to create cache control object here, and then you can call setter method. So here we are setting max age to 500 seconds, set private to true, so private, and here no store is set to true. And basically you can call cache control method, okay, of the response builder, and then you pass the cache control object. Pretty straightforward, right? Okay, so let's do exercise 1. So exercise 1 is basically, we are going to set. So, let's run the cache control application. So cache control, I'm going to run this guy, stop the previous running application, and JAX status caching control application. And then we are going to perform a get operation, and we're going to just observe the cache control directive. That's all. Okay, so it's up and running. So I could actually get the customer, so we could actually get this one, but I'm going to just use the call command. Okay, so call -i and then customer number 1. Then we are basically, you want to just observe this guy, right? Yeah, so I'm going to just copy this code, call. Okay, so you can see cache control is set to private, no store, no transform, and max age 500. Okay, so if you see the code, this is pretty much what I showed you in the slide. So when the get customer, with a particular customer, we are setting the cache. Okay, all right. For your own exercise, modify the value of max age to 1,000 seconds or whatever number of your choice. And try to set other cache control properties. So if you actually see the client code here, I'm sorry, not client code, the cache control code. Okay, so let's see, this is the cache control. So, if you actually see cache control, oops, and you are going to see a bunch of setter method. So you can set the no transformation, proxy validation, whatever. So try to set. Yeah, so we have set the max age and no cache, no store. Yeah, so try no transformation. Okay, to true or false or whatever. Okay. All right, so try to add another one and see whether that works. So basically, when you run the client, then you should actually display that directive. For your own exercise, try to modify the get order method of orders cross-server application. And just like you did here, basically I want you to add this code. Okay, on the server, orders server application and see whether that works. Okay, so I'm going to give you guys about 10 minutes to try exercise 1. Now, let's talk about revalidation of cache data. It's called the conditional get. So what is revalidation of cache data or conditional get? When the data in the cache becomes stale, meaning it expired, so it's considered as invalid. So rather than retrieving the data just because it's expired, it wants to check whether data is still valid. Suppose the data is about 1 million bytes. You do not want to retrieve the data just because the data is, that they expired. You want to actually check to the server whether the data is still valid. That's basically revalidation. So there are two schemes for revalidation. Last modified response header or or ETAG response header. So you can use either scheme or you can use both. So let's talk about how last modified header works. So this is the sequence of operation. So the response contains last modified the response header. Okay, so basically it represents the timestamp of the data sent by the server. So last modified here. Okay. Now client will store this timestamp along with the cache data, and after, in this case, 500 seconds, because that is the expiration date set by max age. Now client wants to see whether data is still valid or not. If it is valid, then it doesn't have to retrieve the data, right? Okay, so that's basically what client wants to do. So it will send get operation with if modified since, and the time is basically the same time that it has received in previous interaction. So you see last modified is the Tuesday 20 May 2015 9:45 EST. So it's going to actually set that value here in if modified since the request header. Okay. And of course, the server application will check whether data has been in fact modified or not. And if it has not been modified, then it will just send 304. Okay, so 304 is basically done modified. And then the client will actually have another 500 seconds for that data. So there is no retrieval of that 1 million bytes, okay? Because data is still valid. Make sense? Okay, so moving forward, that is the last modified. Now, let's talk about how we can use the ETAG. In fact, ETAG is a bit more, I would say, robust scheme than the last modified. So in general, you should use ETAG scheme. So how does ETAG scheme work? So client will send the resource request to the serve application, and the serve application computes the hash, MD5 hash from the resource. And then it will set ETAG response header with that hash, okay, with a 200 OK response. Okay, so this MD5 hash is considered as an ETAG value. So once client receives the response with that ETAG hash, it will cache the response with that hash, MD5 hash. And for subsequent requests, the client will send if non-match MD5 hash value in the request header. So this is the if non-match request header with the hash value, same hash value that it has received previously. And then serve application will actually recompute MD5 hash from the same resource. And if they match, that means nobody changed. The resource has not been changed, right? In that case, it will send back 304, not modified response. And then client will use the response from the client cache. Make sense? Okay. So this picture actually shows the first request and response. So, when the client sends the first request and response is going to be 200, and response header here contains ETAG. So this is the ETAG hash value, and client will actually maintain this ETAG value with a cache. So this is right now is a 9 dB or something like that. And in subsequent request, client will send if non-match request header should set with the ETAG value that it has received right here. Make sense? Okay. And if the server recomputes the hash, and if they match with this hash value, then that resource has not been changed, right? So it will return 304 non-modified response. And the client can then use the data from the client cache. Okay, so now that is the scheme of last modified and ETAG for conditional get or revalidation scheme. So now, how we going to actually handle the scheme using JAX API? JAX provides entity tag class. Okay, so entity tag class has entity tag constructor, and you can also actually set the strength. So it has either strong or weak flavor. So strong ETAG should change whenever any bit of the resource representation change. So this is very strong comparison. Weak ETAG changes only on semantically significant change. So in some cases, the change might be pretty minor, right? In that case, you do not want to actually indicate that something has been changed, right? So you can certainly actually set this boolean with strong true or false. Okay. So if it is true, if it is set to true, then it's going to be weak. If it is false, then it's going to be strong. Okay. So now JAX also supports the checking whether the value in fact matches or not. Right? So in fact, it does have a request the object. So this request object will be injected into your code using context annotation we learned yesterday, right? And the request interface has this evaluate preconditions. The method, you can specify ETAG, you can specify last modified, or you can specify both. Okay, so you can actually use ETAG and date last modified scheme together if you want to, but I think usage of entity tag might be just good enough. Right? Now, what happens is that if you are going to call evaluate preconditions method of the request object passing recomputed ETAG, if it returns valid response header, that means things matched, meaning nobody changed the resource. Okay, so we can actually see that code in the following slide. Okay, so here, this is how you're going to get the request object through the context annotation. So this is what we learned yesterday, right? You should be able to use the context annotation to get this request object injected in your code. Okay, so in this case, first we are going to recompute the hash. So I'm going to call hash code of the customer object. So that should actually give me a new hash value. And I'm actually converting to string. And so I'm passing string object when we create the hashtag object. So we got the newly created hashtag of, represented by this etag variable. And then we pass that etag value, that is the recomputed hash, to evaluate preconditions method. And this request object should actually contain the etag value that came from the client, right? So this request evaluate preconditions will check whether this etag that you have recomputed and whether that matches with the etag value that came from the client. Now, if it returns non-response builder object, that means revalidation on the server was successful, meaning no change has been made to the data. So in that case, we can just return we just set the cache control and we just return the response object. So by the time this is actually returned, in this case, if it is not null, then status code is already set to 304. So you don't have to set 304 yourself, because if it is not null, then it is assumed that underlying library or framework has set the status to 304 for you. So all you have to do is just send the response back. Does this make sense? Okay, all right. Okay, so let's do exercise 2. So here, exercise 2 is we're going to actually try etag server application and then etag client application. So let's run those two. And we're going to actually observe the behavior on the client side. And also I have a sysout println state on the server side as well. So let's just make sure this is the result that we get. So stop previous running application. And then let's actually get the etag server. Let's run the etag server run as Java applications. And let's run the client, run as Java applications. Okay, so this is the client-side code. Read the customer the first time. So etag was returned 1595, something like that. And then it's going to read the same customer with if not non-match set with this value. And then the server responds back to 304. Obviously, nothing has been changed, right? So now if you take a look at the server side, let's take a look at the console of the server. So this is the server side. So this is the server side. So first time get is called, obviously it should not have any if non-match, right? The revalidation on the server was not successful because there's nothing to compare. Now the second get, it checks the value of if non-match coming from the client, and then it will recompute, and then it will send back 304. Revalidation on the server was successful. Okay, so that's basically what we observe here. So if you take a look at the server-side code, so we're basically dealing with just the get particular customer method. So we are using Hadoop Programming notation of if non-match. So we are capturing that request header value as if non-match, and you also get the request object, right? So we have a system out println statement. We just get the customer object. Customer is not null, then we throw the exception, and then we basically display if non-match. The first time the get method is received, it should just have no if non-match is sent by the client, because that is a first interaction. Now second interaction should have this value, right? So that's what you're actually seeing right here. Okay, second interaction should have if non-match, right? Okay, and then we are recomputing the hash value. Again, this is the same code that we have seen. So we call hash code, and integers to string. We create the entity tag, okay, and then we call the evaluate preconditions method with tag that we just computed. So this is the recomputed hash, and this evaluate preconditions method will compare this tag value that you have recomputed with tag value that came from the client. And if it returns non-null value, okay, if it is not null, that means the comparison has successful, meaning comparison successful, meaning the nothing has been changed. Okay, so if it is not null, then you can assume that HTTP status is set to 3 or 4. Okay, so the so basically all you would do is basically call the build method to get the response object and then just return. Now if it is null, okay, then the control goes over here. That means the resource has been changed. So basically we are going to resend the data. We are calling entity method of the response builder to send new customer data. And then basically we are also sending the tag. So this tag should be a different value than the previous tag, right? Okay. So this is a case when the match was unsuccessful, meaning data has been changed. Okay. This is a case that data has not been changed. So in this case, 3 or 4 will be returned. So that's the server-side code. Client-side code is, basically we perform initial get, and then we are doing the second get. So initial get, we are going to call get entity tag. So it's going to return entity tag object, right? And then we are basically displaying that value. And then for conditional get, meaning the subsequent get, we are passing that tag value as a value of if non-match field. Okay. And if everything is working as expected, then it should return 3 or 4, and that's basically what we have seen. That's what we have seen here. Okay. All right. So for your own exercise, I want you to modify the get method of order resource web application to handle conditional get, and also change the orders client code to do pretty much what you see in the customer client code. Okay, so I'll give you guys about 10 minutes to finish exercise 2. Next topic is concurrency check or conditional put. So this is something like optimistic locking in persistence in relational database. So conditional put. So concurrency issue. So if there are multiple clients trying to modify the same resource concurrently, they will override each other. So this is a race condition that you see in typical the database environment. So same issue here. So conditional put addresses the problem. So it is similar to catch validation scheme, but this time it is more or less actually checking whether something has been changed. Yeah, so it's checking whether something has been changed by someone else actually. So when updating with HTTP put, client will set if match request header to tag that was returned previously. And when the server application checks the tag value in the request header of that put request, again it will check whether it matches the tag value that it recomputed. If no one has changed it, then they should match, right? If it doesn't match, then somebody has changed it, right? So in that case, precondition failure 412 should be returned. So when the client, when it received the 4112 error condition, it should reread the data and change the data and then perform another update operation. So this works exactly like optimistic locking situation. Okay, so that is the exercise 3. So let's actually do exercise 3 here. Again, we are going to run the server application, conditional put tag server, and conditional put tag client application. When you run the application on the client side, you're going to see this response. So let's actually run it and see whether that is in fact the result we expect we get. And then I'm going to just use the lab documentation to explain it. So we are going to run, this is the, okay, so this is the server, run as application. And then, okay, so it's up and running. Yeah, now we're gonna run the client. Run as Java application. Okay, so it's going to, yeah, you can see this is the result on the server side, okay, on the client side. So let's take a look at the client side first. The client side. So it's going to read the customer for the first time. So it should return 200 and e-tag value is 15 something. And then it will try to update the same customer with if match server header set with, yeah, so this is the value that is set. And it will return 204, no content, and it should return the different e-tag value because things has changed, right? The last thing it will do is basically it will try to send incorrect e-tag value, okay? And it's supposed to return 412, but it actually returned 400. So I couldn't actually figure out why it's returning 400 instead of 412, okay? So anyway, so that's what you see over here. On the server side, you know, put is called, so precondition is met. So the first time, you know, nobody else has changed, right? So it should actually set precondition is met. And the second time, you know, is basically precondition is not met because we actually send the bogus value on the client side. So I'm gonna actually show the code in the following, in a few seconds. So this is the server side code. So again, we would see, you know, once a server received the put request, this is a put request, right? It will recompute the e-tag, okay? Then we are again calling evaluate preconditions method passing e-tag, okay? And in this case, if the value and newly created e-tag above do not match, it means somebody has already modified the data. In this case, evaluate preconditions tag returns the response header, response builder initialized with the error code 1412, but you know, the actual result running the code, it actually set to 400. So if it is not null, then the precondition is not met. So this is a little bit of reverse of a conditional get. In conditional get, if it is not null, then they match. In the put case, if it is not null, then they do not match, meaning somebody else has changed it. So here, you know, when you have not null response builder object here, that means the response has been set to 412, or in our, you know, in our example, it is set to 400. Okay. If it is null, then preconditions are met. Okay. So nobody else has changed the customer. So in that case, we are going to actually update it, and then we are going to send the response with no content. So this is setting 204. Okay, you know, basically 204 because there is no reason to send it back because the client already has that content anyway, right? When it's actually performing a put operation. And then it's creating a brand new tag, okay? So it's actually creating a brand new tag value using tag method and then calling build method, and that will return response object, and then that response object will be returned to the client, okay? Now, if you take a look at the client code, again, we received the tag, e-tag, and this is the first conditional put. Okay, so we're going to actually pass e-tag value in each if match header and passing newly updated customer. So, you know, basically we are just updating set city to Milton 2. So this is an, you know, new customer object that we are going to use to update the customer. Okay, and so when you receive the response, it's going to check e-tag. Okay. And so this one should actually, you know, should return 204, right? Because they should match. But in third case, we actually passing kind of bogus value. Instead of actually this e-tag, we are just actually sending 1, 2, 3, 4, 5, 6, and 7, which is certainly not the same value of e-tag. In that case, the comparison should fail, and in that case, it will return 400. Okay, so that is basically, yeah, that's what you are seeing here. Okay. All right, for your exercise, modify the put method of order resource of the order server application to handle conditional put. So basically, you're going to add conditional put to order server and client application, as you have seen in the customer server and client application. Okay. Okay, so I'm going to give you guys about 10 minutes to do that exercise, and then we're going to move on to new topic.